Yes, heating curve of a pure substance. Pay attention, pay attention. Heating curve of a pure substance. This is very simple. This is very simple. Just pay attention. Number one, we have this diagram you can see here. This is negative 10 degrees. This is 0 degrees. This is temperature 100 degrees Celsius. Then we have time in minutes. Then look at this. This curve, when it gets here, it is constant. The temperatures are not increasing, same as D to E. And then we have increase in temperature as well as time is moving. Pay attention. Let's go to the question number one. State the kinetic theory of matter. So, Max, state the kinetic theory of matter. Yes. What does the kinetic theory of matter say? Yeah. The kinetic theory of matter states that all matter is made up of tiny particles. Let us write the kinetic theory of matter states that all matter is made up of tiny particles. Yeah, tiny particles. These particles are also called, they can be atoms or the molecules. Yeah, tiny particles which are in constant motion, which are in a constant motion. That is to say that these particles, either in solid or liquid or gases, they are in continuous motion. So the way the particles vibrate in solid is not the same as they vibrate in liquids or in gases. But basically, all particles in matter are in constant motion. All right, let's go to the second question. Explain what happens to the substance between A and B. A and B. Look, this is A and B. What happens here? Yes? Yeah. All right. Let us write as you have said. So, first of all, let us know the state. Which state is this? Negative 10 degrees all the way to 0. This is solid. Yeah, this is solid state. So at this point, the temperature increases as the particles absorb heat energy. So here they absorb heat energy and then they continue vibrating continuously. Let us write. We say the particles of the substance vibrate in a fixed position. They are not changing the state. This is the solid. This is solid. So up to here, it is solid. So they are vibrating within a fixed position. Fixed position. Another point on the same, what can you say? As these particles are vibrating, what are they doing? They are gaining kinetic energy. Hence, there is rise in temperature. So, the temperature, the temperature rises as the particles gain heat energy. That is heat energy here. Therefore, the particles are vibrating. But up to B, they change the state. Somebody was asking, why is B to C flat? That is, the temperature is not increasing. Yeah, yeah, at B to C, temperature remains constant. What happens to the temperature between B and C? What do you think is the answer to this question? Yeah, it is very simple. Yeah, the temperature. What happens to the temperature? The temperature remains constant. The temperature remains constant. Let us explain this. The temperature remains constant as the substance which was solid form is now melting, changing the state to liquid. So all the kinetic energy, the heat energy, which had been uh, absorbed here is now used to break the walls. To break the walls, or the forces, is used to break the forces of the attraction of the particles. So now the particles are now changing to liquid form. So here the temperature is not increasing because the energy is being used to break the forces of attraction. So now we come to C to D. So between C and D, what is happening? The state, first of all, now from C to D, it is liquid. Yeah, it is liquid state. So if it is liquid, what happens? Now the particles are gaining heat. They are vibrating. We have the kinetic energy here, and then is absorbed, and now it is used here. At this point, this is the boiling point. This is the boiling point at which now the liquid starts changing from liquid form to become gaseous form. So the temperature again is constant at D to E because of the energy that is being used now to break the forces of attraction within the liquid. Now it becomes gases at this point, and so on. So at this E to F, it is gases, and the particles are now moving freely. Yeah, in all directions. The particles here are moving in all directions. Here they were vibrating within the fixed position, and here they were now the forces of attraction in the liquid are weak. So now they are that's why liquids can flow and so on. So very simple.